Hi everyone. So today we are going to do a very easy level lead code problem. So the name of the name. So what we do, we have to just move all the zeros to the end. So that's it. So we are given an array and we have to move all the zeros to the end. So basically now, yeah. So while moving arrays to the end, we need to maintain the order. So in the process of moving elements to the end, we need to keep this order. So 1, 2, 3, 4, and 7. So it should not get messed up. So so we can't, keep one left pointer and right pointer and keep exchanging the zeros whenever my left pointer is a zero and the right pointer is not zero. So if we do like that, it will get mixed up. So we need to maintain this order. So there are mainly two ways of. So one of the naive way, is to create a new array, right? And then iterate over this first array if it is equal to zero. If it is not equal to zero, you put it into that array, and then if it is equal to zero, you just skip and move on to the next element. So, but yeah, that would take overfn time, but it would also take overfn space also. So now let's try to do it taking overfn time and off one space. So that is without creating any new array and stuff. So how we are going to do that? So we will first, there are two ways to do this. So we'll first see the swapping approach. So what we have here, so we have LP and RP, both of them are pointing to one, right? So both of them are pointing to a non-zero element. So what we do, first thing if they are pointing to, so if RP is pointing to a non-zero element, right? Zero element. So if RP is pointing to a non-zero element, we swap it. So whatever is there in LP and RP, we swap it, the LPs and RP space, and then we do LP plus plus and RP plus plus. Both of them we just increment, right? And then, so this is what we do. So first thing, if both of them are not equal, right, we just move them. Again, I see, okay, both of them are not equal to zero, right? We just move them. Now both of them are equal to, so now RP is equal to zero, right? So so if RP is, so else we'll just add one else here. Else, okay, RP is equal to zero. Yes, it is. So in that case, what we do, uh, so if RP is equal to zero, RP is equal to RP plus 1. So we just do RP plus plus. Now in this case, RP is equal to 0, it will come to the else block, right? So we just do RP is equal to RP plus 1. So now again, we will keep looping while RP is less than ARR dot length. So now if while we keep looping until this one, so now again RP is not equal to 0, right? It is not equal to 0. So when RP is not equal to 0, so we swap it. So we swap the values of, so this becomes 3, this becomes 0, and next we'll do LP plus plus and RP plus plus. So we will do LP plus plus and RP plus plus. So now in RP is less than array dot length. So if RP is not equal to 0, so is okay, RP is not equal to 0. So now again we swap it. So So this becomes 0 and this becomes 4, right? So next we do LP plus plus and RP plus plus. LP plus plus and RP plus. LP plus plus and RP plus plus. So now RP is still less than array dot length. RP is not equal to 0. RP, so RP this time RP is equal to 0. So RP is equal to 0, so it will do RP plus plus, right? Now again, RP is not equal to 0, so but this time RP is equal to 0, right? So it will just do RP plus plus. Now RP is now RP is not equal to 0, so this becomes true. So we swap it. So we just swap it. So 7 comes here and 0 comes here. After swapping, we do LP plus plus and RP plus plus. So now LP is RP is not equal to 0. RP is 0. So next, so RP is 0. So it will just do LP plus RP plus plus. So it will come out and yeah, we will have the array like this one. So all the elements are moved towards the end and we can return this array. So yeah, let's code this implementation. So let's do that. Yeah. So now, so what I had said, so we'll keep two pointers. So intlp is equal to 0, intrp is equal to 0. So now while rp is less than arr dot length, is less than arr dot length. So if rp is not equal to, so if arr of rp is not equal to 0, so we swap um, lp comma rp comma arr. So next we do lp plus plus to rp plus plus. So after that, so else we only do, it is pointing to 0th element, we just do rp plus 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 plus. So now we can, after doing these operations, just avoid, yep. After doing these operations, we can return. Now let's run this. Now to code our swap method. So ARR LP, RP, next. So int 10 is equal to ARR of LP, next. ARR of LP is equal to ARR of LP is equal to ARR of RP, next. ARR of ARR RP is equal to temp and yes, so as you can see, we have got it. So all cases are passing. So yeah. So now this, so if you analyze complexity, it will be of n time and of one space. So now what we do is, I'll teach you one more method, right? So let me just rewrite the question. Let me just rewrite the question. So 1, comma 2, comma 3, comma 4, comma 7, comma 0, comma 0, comma 7, comma 0. So now what we do is, so we iterate through each of the array, right? So using the main index, we get the array. So whenever the main index I, we are iterating through this array, right? So we keep getting these numbers. So and then we have one count variable also. Count will only increase from 1 to 0, 1, 2, 3, like that. Like incrementally it will increase. And whenever we come across a non-zero elements, we store it in that count of I. So let me explain what I'm doing that. So count variable will have, right? We'll have one array index. So I will iterate through this one, and count will be incrementing. So it will start from 0, comma 1, comma 2, comma 3, comma 4, like that. So this is what we'll be doing. So if count, so basically, so so ARR of count. So if if ARR of I is not equal to 0, so it is not equal to 0, we store it in ARR of count. So this is the main condition. So let me rewrite this again. So if ARR of I So ARR of I is not equal to 0, right? We store it in ARR of count, like this. So now what happens? What happens? So now I is here, right? And count is 0. So now count is 0. So I is not, ARR of I is not equal to 0. So ARR of count is equal to ARR of I. So count is 0. So on the 0th element, 1 will be, it's already stored. So next I will do array, so I plus plus and count plus plus. So count plus plus I plus plus and count plus plus. So now if I do array of I plus plus, so we move I to here. So next we do count plus plus, so count becomes 1. So count is a non-zero element. So array of I is again not equal to 0. So array of count is equal to array of I. Yes, so it's already 2. So next I plus plus and count plus plus. So we will I do an I plus plus and a count plus plus. So now again it is 4, again it is pointing to 3, so no change, right? So the same thing happens. So increment I and increment to 3. So next again it will do I plus plus, right? So after that it will do I plus plus and next again it will become 4. So now now we have I plus plus. So we won't make any changes here. So if it is not equal to 0, we just keep going. So I will still be pointing to the fourth element. So this is the 0th element. This is the first element, second, third, fourth, fifth, sixth, seventh, and eighth. Right? So if it is not equal to 0, okay, it's not equal to 0. So okay, so it is now equal to 0. So we just keep incrementing I plus plus. So once we increment I plus plus, it will go to the next element. Okay, it is again not equal to, it is again equal to 0. It will do I plus plus. Now, now we'll come across 7. So it is not equal to 0. So array of count. So what is count now? It is, so it's, should be 0, 1. So this one, so yeah, I think I did a mistake. So I should be, so count should have been 5. Okay, so if count is 5, so now it is not equal to 0, right? So it is equal to 7. So IRR of count, so which is 5, so this is equal to IRR of 5. So this will come 7 here, right? So after doing that, 7, I'll increase I plus plus. So just increase I plus plus. Next count will become 6, right? So count will become 6, and next again ARR of I is not equal to 0. It is equal to 0, so I'll do I plus plus. It will come out, and this one ends. So in the end, we'll be having this array, right? So we'll be having this array, and next count will be pointing to, so count will be pointing here. So whatever count is pointing to till the end, we can just make it 0, 0, 0. So after this, after this while loop, while I less than arr dot length, after this loop, we come, so while I is less than, so while count is less than arr dot length, arr of count, we just need to make all of them 0. So I hope you got the solution. So whatever we are doing, we're just going through each and every element. We are putting all the elements which are non-zero to the first one, and yeah, all the elements, all the non-zero elements, all the n non-zero elements will be in the first n positions, and then after that we can just fill them with 0. So let's code this. So I'll just keep int I is equal to 0. So I'll keep int count is equal to 0. After that, if array of I, if arr of I, okay, okay. So while arr of I is less than, shit, while I is less than arr dot length. So if arr of I is not equal to 0, it is not equal to 0. So arr of count is equal to arr of I, right? So if arr of I is not equal to 0, arr of I is So next we just do I plus plus and count plus plus. And next, what I will do, else, else we just do I plus plus. So after this one, while count is less than dot length, so we just error of count is equal to error of count is equal to 0. Run. Okay, so as you can see, all the test cases are being passed. So this is the two ways to do that. So yeah, thank you for watching.